I vibed so hard and got so far, but in the end, I still can't merge the fucking PR.
Thanks, Randall. But we're going to look at Go, okay?
Go has a
How much do you want to bet that I'm going to disagree with this video? What do you think is like the likelihood that I disagree with it? And what are the good parts? None? Okay, you'll shut your dirty mouth. There's plenty of good parts to Go, okay? But let's find out. What are the bad parts? I swear to all that is nice and pretty in my life, if I hear one if or does not equal nil, I'm going to just jump kick, throat chop this guy. Same time, okay? Very hard to do, especially since a lot of stretching goes on in that move.
Go has a lot going for it.
Okay.
It is developed by some of the most prolific software developers in the world. It constantly ranks high in various developer.
By the way, out of all people in this list, it's like, I definitely know this guy. I definitely know this guy. Who's this guy? Poor, what's his name? Robert? I have no idea who Robert is. Poor fella.
Constantly ranks high in various developer surveys, and it is a darling of the tech community. On top of that, it enjoys some of the best publicity thanks to the large companies and
1 to 1. If Go is bad, does that mean that Come is good?
I gotta turn off TTS. That's what that's what I gotta do right now. I gotta turn off TTS immediately.
Successful projects who are actively using it. Just
Is that Netflix, by the way? Is that Netflix, by the way? This shirt is literally like 12 years old. All right, anyways.
recently, for instance, the TypeScript team announced that they're porting their compiler and toolset to Go in an attempt to speed up performance.
Weird. You know, it's kind of weird that TypeScript team would choose Go. I mean, I thought everyone choose Rust for this. By the way, Rust is actually a pretty good language when it comes to compilers. Like, there's a lot of benefits, obviously, to use Rust. It's pretty dang quick. But geez, why? Why would you use Go? Oh, wait, are you telling me that it's easy to make things in Go? Oh, is that why?
And simplify their build pipeline. That's no small endorsement. When a language created by Microsoft engineers starts leaning on Go to improve its tooling and the resulting performance is magnitudes better than before, you know Go's doing something right.
Can I also just interject for a second? The fact that it's 2025 and the TypeScript team at Microsoft is finally writing their compiler or their transpiler, whatever the hell you call this thing, from TypeScript into a language that is not horrifyingly slow at this activity is shocking. It's been around for like 12 years and TS Server just crashes constantly. Like the actual primary function of TS Server is to use all your memory and then crash. I am just shocked it took this long to be like, you know, we should just like fix this, huh? That like, you know, it'd be a good idea. We just fixing this.
But despite all Go's success, it's not all sunshines and rainbows.
Okay.
It might sound surprising, but while Go is an amazing language, it also has its bad parts. And I think everybody who plans to learn or use Go in their next projects should be aware of this caveat.
You know what the worst part about Go is that channels feel really nice to use and then you overuse them. There's like almost very few uses of channels you need. Just pretty much don't use them unless if it's like really, really needed. And then all of a sudden it's easy.
For a bit of context, I'm a software developer with more than 15 years of experience, and during this time I worked mainly with Java, Kotlin, and TypeScript. For the past year, I decided to transition to Go in all my personal projects for the reasons we all know by now. Go is simple, fast, efficient, it has great tooling, and it is a breeze to compile and deploy. But after actually writing Go for a while, I realized things are a lot more nuanced, and not everything lives up to the hype.
Okay.
Let me explain. This doesn't mean Go is a bad language. However, we need to paint the full picture because just like Go has some amazing parts, it also has sharp edges that you only discover once you spend real time building something non-trivial with it. The design decision.
I do love that there was recently this like up in arms, everybody's super angry at Go because they finally decided after, 12 years to fix the fact that a for loop was referencing or was keeping the same variable in the loop over and over again. In 1.21, they finally were like, all right, guys, fine. When you for loop now, we'll stop doing that. We'll create copies of the object so you don't accidentally mutate everything and you don't have references that end up pointing to whatever the last variable was, right? It's insane that it took that long.
Decisions that make Go such a powerful tool also have
Hours of my
drawbacks.
life. Yeah,
They
I know, it's
impact
insane.
the way you write
And then when you finally make the switch over, you also lose hours of just doing stupid stuff. It's hilarious.
code, especially if you already have a standard and a set of expectations based on working with other languages. So here are 5 things you really need to know before switching to Go.
All right,
It was
5 good ones.
surprising to find out that based on some Google searches, apparently I'm not the only one noticing these things. One of Go's biggest selling points is its simplicity. To be fair, it really does look simple on the surface. There are few keywords, the syntax is minimal, and the official docs go out of their way to keep the language easy to learn. But once you go beyond the tutorial,
But that's kind of funny. That was pretty good. I don't know. Maybe I'm a child. Maybe I'm a child.
you start realizing that Go's simplicity is mostly skin deep and it often comes at the cost of expressiveness. It's the little things we
Isn't that like literally the trade-off? Isn't the trade-off of a language that's super simple is that you're not meant to express complex states? I mean, I don't think that this is a negative thing. I think this is like an actual design principle. Hey, we're going to just make you use if statements for the most part. That was like the goal was like, hey, if statements are pretty good.
which start to nag you after a while. For instance, even though Go has a while loop, it does not have a while keyword. You just write a for loop and skip the condition. This forced syntax reuse, just for the sake of saving a keyword, makes reading code more difficult than it needs to be.
I don't like this point. I'm just fine with that. I don't really care. Right? Like, this is just like such a... I want to use the term non sequitur, but I'm afraid I don't know what that word means, and I'm going to sound like a butthole using it. So I'm just going to say this is a non sequitur. You know what I mean? It's just like a little bit non sequitur. L take so far. This is, to me, this just doesn't matter. I don't care. Like, honestly, if your language doesn't have a do while loop, I don't care. Right? They're all the same after that.
The same problem extends to public and private modifiers as well. Instead of
Okay, now that's very different. The obvious answer is this, that everything should be public unless if it's made private. Call me wrong here. I think Rust got it wrong. Yeah, I said that. Rust got it wrong. True, like, dude, the amount of pubs the pubs per second I used in Rust was just so frustrating. Pub. Hey, what's that? What's that? Pub? Oh, yeah, we're going to pub that one. Hey, what's that over there? Pubbing it. Pub that guy. Pub that guy. Pub that guy. Dude, so many pubs.
using clear keywords, Go uses capitalization to determine visibility.
Yeah, I mean, that's
While
so
this
stupid.
approach is concise, it's also easy to overlook.
You want to hear a fun fact about me? In Go, I refuse to have a private type. As simple as that. The fact that capital letters are what determines public and private, I literally refuse to have a private type. I'm not going to make a lowercase type. That's genuinely a crime against humanity. I think it's capitalism's fault. It's just like, I just refuse. Like, I will never specify a lowercase type. The end. I don't care how private it is.
Especially when refactoring. Change the case of a function name, and you've potentially broken your entire API without any compiler warnings. And let's be honest,
Wait, what? Yeah, of course you. If you what? If you changed your the case of your method, of course there's gonna be compiler. There's gonna be compiler. No, there won't be compiler warnings. There'll be compiler errors if you reference it. ¿Por qué, Maria? Like, it's not that. I mean, Go is a compiled language. It's gonna be like, dog, this thing doesn't exist. Like, what are you talking about?
enums are no better.
Okay,
Go
enums are
doesn't
fair.
actually have real enums, just a workaround using const and iota. It feels more like a clever hack than a proper language feature.
I mean, this is like just really simple enums, right? These are like C-style enums. It's just a number. These are just C-style enums. Like, they're I don't like them. I like more complex enums, but I don't know. No, it's not. It's a hack? Isn't just your basic old enums literally a number? Well, in fact, to be completely fair, no. Yeah, these are just like old these are just old enums. It's literally the same as C enums. Yeah, I'm not crazy. Dude, you guys made me second guess there for a second. I'm like, wait a second, do I not know C enums? And then I realized, no, I'm not the problem. The kids are the problem. You guys are the problem. Also, the word enum and Rust's use of the word enum is a crime against humanity. They're union types. Okay, they're tagged union types, if we're going to be fair here. All right, just completely fair. I'm not the problem. You're the problem, okay? They are no worse than C enums. C enums are closed, I'm pretty sure, and Go are open. Not your standard enums. Your standard enums, like you don't have to define them as that specific type. You can just pass in anything. That's always been the big complaint about enums, is that you can just like, oh, your enums are 1, 2, and 3, like red, blue, and green, and then you just pass in 69, and C is like, oh, that's an int, right? I'm not saying they're good. I don't like those enums. I like better enums. I'm on your team. I'm on team better enums, right? Also, I don't think I don't think these switch statements are bad.
There's no type safety, no grouping, no scoping, and nothing stopping you from assigning any arbitrary value to what's supposed to be a well-defined enum. It's like Go wanted to look simple and minimalist at all costs, even when this means hiding complexity instead of eliminating it.
I just, in my head, what I think is that people who were really excellent at C made a language that's easier to use than C.
One of Go's more distinctive features is the ability to return multiple values from a function. At first, this feels elegant, especially when handling errors. No exceptions, no try-catch blocks, and no special error types. You just return the value and the error and simply move on. But this elegance fades when you need to do anything sophisticated with these return values. The fundamental issue is that multiple return values in Go aren't actually tuples or first-class values. You can't store them in a variable, and you can't put them in a slice. You can't send them through a channel, and you can't abstract over them with generics. This seemingly minor limitation cascades into significant verbosity throughout your codebase. Let's consider the common scenario.
I could see why it'd be nice to be able to, I do wish there was like an easy way to do channels with just like, here's my list of values, right? Like that would be sweet. I would like that. Fair. Like, that's fair, by the way. That's a fair one. Being able to put it into a list or a slice, I get that. That'd be nice. Fair and factual.
Of processing multiple items in parallel and collecting all results with their potential errors. In languages with proper tuples, you'd simply collect the result error pairs. In Go, however, you're forced to create a custom struct type just to package these values together. The unnecessary boilerplate code is what made me run away from Java in the first place. I was simply sick of the never-ending POJOs and the verbosity. This might seem minor if you're building simple applications, but as your codebase grows, the verbosity compounds. You'll find yourself creating countless small structures just to bundle related values together, adding ceremony that distracts from your actual logic.
Okay, that's a pretty well thought through one. Okay, I would say that was actually a pretty well thought through argument, but I think that the framing of it as multiple return values is not that multiple return values are bad. I like multiple return values. I'm glad that he didn't say if error does not equal nil is a big problem. I think that's great. Bro, never heard of error group? Yeah, I mean, obviously error group can work here. Either way, that's not quite. I mean, it only sort of works here. Like just being able to use it in a channel, right? Right? Being able to use this in a channel would be super fantastic, right? Just to be able to be like, hey, I want to shove through this channel some sort of value plus an error, right? Like that would be nice, right? So far, apart from enums, everything listed here is bad is exactly why I like Go. I would like a little bit better handling of multiple values. Like I could understand why that's good. I think that section was pretty well formulated. I do find myself making a bunch of like little structs here and there, but it's also super, 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 super simple in Go. So it's like, it doesn't necessarily bother me.
Go's error handling is probably one of the
I'd said if he does this one, I'm going to hate him, right? This is not a good argument.
Most common complaints whenever developers are first exposed to the language. And, let's be honest, managing errors in Go is extrememly verbose. The chances are you'll write the same 4 lines of code over and over and over.
This, first off, this does not bother me. I just want to say this does not bother me. I like explicit error handling. I'm actually less fan of question mark code. I actually don't necessarily. Don't look at that. I actually don't really like that about Rust, and the only reason why I don't like it about Rust isn't because it's not that I dislike convenience. It's that I just hate the fact that you'll see something that looks like a method, and then you'll have like a question mark, then you'll have like a dot await, and then you'll have like another thing that comes out, and then there's like another question mark, and then there's like another await, like if anyone's ever worked with some of those things. And it's just like, man, there are so many things going on in this statement. It's such a terse statement, and so much of this is just difficult, right? I have always hated that. Explicit, I think, yes, there is this. Yes, this is an 8 equals D. I got a good joke that I've been kind of working on. Okay. Yeah, I got a good joke going on there. You have a choice, though, in Rust. You do have a choice, but the reality is that 99% of error handling feels like it's just lazily handled and just tossed up, right? And I just find that there's a lot of behavior mixed in these lines. So when I glaze over something, I don't like to see I don't want to see 90 operations, right? I find that to be very it's a lot in your head to hold into place.
Over again.
I'm not a
Go
huge
calls
fan of
this
super
explicit
terse-
error handling, and it
super
has its
terse
benefits.
languages.
Good software is predictable and safe. So having to deal with errors explicitly
Did he just say good software is predictable? I could predict these errors are coming out, right?
forces you to acknowledge when something can go wrong and handle it right away.
Yes.
But there is a big difference between being explicit and being repetitive. The language lacks even the simplest tools to streamline error handling. Rob Pike, one of
I don't currently consider that a really big problem. I have yet to really consider that a big problem for me. I don't know. I guess I just don't see it. I just don't see it as I just really don't see it as a huge problem.
Go's creators defended this choice. He argued that explicit, repetitive error checks improve readability and keep control flow obvious. So, in a way, it all boils down to the coding style you prefer. But, let's be honest, people are comparing Go's error handling with solutions offered by Rust, for instance, and they do have a point. There were efforts to improve the situation, and we even had a proposal to add a built-in try mechanism in an attempt to simplify error handling, but it was shut down because the community feared it would ruin Go's simplicity. This is one of those design decisions which you either love or hate. Go's inheritance approach faces the same issues since its creators argue strongly against the complexity of languages like Java. In their view,
Yeah, I agree. I don't want inheritance. I'm okay with this. 75% of code being error. Okay, so I can always tell when someone has never written Go because of this. Like, I can just tell. Like, have you written anything complex in your life? Or do you literally just write, like, 2 calls out to a server? Like, you're right. If you call something that inherently is asynchronous is going to fail, you're going to have to handle errors. But if you've written something of any sort of value, say like a compression or anything that's complex, you're just going to have very little. You're just not going to have that many if errors, right? I make 3 calls to a server. Yeah, okay, then you just haven't written anything complex, right? That's all that means.
Inheritance led to fragile, tangled codebases. As a result, Go's official philosophy is to avoid inheritance and favor
They have
composition.
embedding, though.
This is a fair point, but in running from one problem, they might have created another, especially for developers coming from stricter backgrounds. Embedding in Go might trick you into thinking it's inheritance, but it is actually a different beast entirely.
It's
This
confusing.
approach makes Go code simpler and more predictable in many ways, but it does mean that developers coming from traditional OOP languages need to adjust their thinking. Go isn't trying to be a partial OOP language.
I just don't think embedding's good, just generally speaking. Every time I've used it, I think I've just generally regretted using it. That's all. Good idea, questionable implementation. Yeah.
It's offering a
It's just
different
weird.
approach to code organization altogether, trading some of the flexibility of inheritance for clarity and simplicity. Go was initially designed without generics, and that decision did limit the language for over a decade. Generics were finally introduced in 2022, but with a design that maintains Go's philosophy of simplicity over flexibility.
Generics are the only thing that has ever been implemented in Go that truly nobody really got what they wanted out of the deal. Like, there's some things I like about generics. I have a couple. I like that you can have like a generic. I have a couple like generic JSON things that are really nice. I have because I have these typed value. I have these boxed values that are going to be, some of them are going to be JSON stringified, and so it can do this JSON or it can do this JSON parsing via a typed value, and then if it doesn't get the specific type out, it just returns the error, and it can do all. It does it has some like nice handling and all that, and it uses generics, but you can't use them on method receivers in a way that I like.
While you can now create generic types and functions, there are still limitations. You can define methods on generic types, but you can't add generic methods to non-generic types. Go doesn't support function or operator overloading, and its type-constrained system, while powerful enough for many
I'm okay with no operator overloading, right? I'm okay with that. Rigid type system, just throw an interface behind it. I mean, that's
use
the whole
cases,
point.
doesn't provide the full expressiveness of traits or type classes found in other languages.
I'm
This
fine with
aligns
that.
with Go's fundamental philosophy of prioritizing clarity and readability over expressiveness. The language encourages explicit, concrete code over complex abstractions. This approach has benefits for maintainability and onboarding new team members, but it can lead to more verbose code in large systems where more sophisticated abstraction mechanisms might reduce duplication. So, at the end of the day, it all boils down to expectations.
Yeah, I mean, but the more sophisticated your abstractions are, the more like time you have to spend thinking about them. I think that's the whole trade-off, is that you can be dumped anywhere in any code and Go code base, and generally speaking, you just like read through it top to bottom, left to right, and you're like, oh, okay, I see what this is doing, right? Like that's supposed to be the thing. You don't have to be like, okay, what does this macro do? Okay, what does this abstraction do? You don't have to like play the game of go back up the hill. You get to have a much simpler time understanding.
And
I think that's the whole
philosophy.
trade-off.
If you
Even though it's
expect
more
Go to
like,
match the
it
development
definitely takes more
experience of
lines
a
of code to
high-level
express the
language
same
with
thing.
lots of syntactic sugar, you will be disappointed. But if you're looking for a fast, reliable, no-nonsense language that gets out of your way and compiles in milliseconds, Go is the right tool for you. Just go in with your eyes open, because there's a huge difference between liking a language after watching some YouTube videos and actually still enjoying it after maintaining a real-world project with real users, edge cases and deadlines. I expect this one might hit a few nerves, so please keep it civil in the comments. If you like this video, you should watch one of these ones next. Until next time, thank you for watching.
Yeah, I really, the only thing I honestly didn't like about it is the if error I think there's just like, everything else, it was fine. It was fine. I do agree with the channels and multiple values. I think is crazy. Embedded is just kind of out there. You know, the problem about, honestly, the big problem about this video is that they didn't address any things that actually make Go really annoying to use. Such as like, if you want to properly use channels, you really need to couple it with context. Because you can accidentally use a channel in such a way that you just get really bricked experiences. Because channels are just like, they're just not that great. Right? Like they're just so close to being great, but they're just good instead. And so then you're just really frustrated with it. And so then you have to have like this whole context game playing around, and then you have to do this whole like select statement on top of them because of just crap and checking, and it's just like, that's annoying. Like I don't want to have to know if I can't write to a channel, right? Like that's just not a great experience. I don't want to have to play the game of, if you write to this, you could be like exploding things. It's just annoying. I don't want to have that. I don't want to have a function that I have to go check to see, can you even write to it? I don't want to have to do a recover call, right? I just don't want all of that stuff. I want to keep it in a more simple universe. You know what I mean? A recover call, you can panic and recover some certain things. And if you panic and recover, you can kind of come back from. Like, I hate the fact that there is a try catch in Go, which is panic and recover. And then there's also like standard errors, because there are some things that do panic and recover. And it's just like, right? But there's also some ways you can't really get around it, right? In a web server, there's things that can go wrong. And if you were to write like a proper web server, you probably want to wrap all of your handlers in a panic recover, because you want to make sure that if for whatever reason one of the endpoints panics, you can still recover and keep your web server running. I mean, I guess that's more of a philosophy of argument. One would argue maybe you do want it to actually go down. Like maybe you do want it to break and saying, hey, this is the reason why it broke. I guess you could probably make the counter argument. I go kind of back and forth on which one I'd prefer. I don't know. Anyways, there you go. Nice. I still like Go. I still write stuff in Go. I still enjoy Go. But I will be fair. There is a 500 internal error server does Sudoku. Well, that's the thing, is you can still internal error without Sudokuing. You don't need to solve a bunch of numbers just because you internal error. Like you can still just be like, I handled the error because it's a value. We just couldn't proceed. It's a 500. Let's go. Not finish the project now. I went in, so my 11 streamer is all in, like how I do all the voices and handle Twitch chat and all that. That's all done and go. But I am strongly considering Elixir. Like I might just take the plunge and just start learning how to write servers with Elixir, right? That's what I want. I hear Elixir is truly the best language, and TJ will not stop saying it's the best. TJ, it's really TJ. It's not even Ryan Winchester. TJ just won't stop building things in Elixir. I think secretly, deep down, TJ says he loves OCaml on the outside, but on the inside, he's just an Elixir boy. He tries to pretend like he's a OCaml guy on the outside. He's an Elixir boy on the inside.